Hey guys, Cameron on here. I know it's been a while. I've been working on a few other projects for you guys. Some things have came up. I got a hiccup. I don't know what to tell you. Um, anyways, today's video is going to be a little bit different from everyone else's from the other videos. Today's video is going to be a how-to video. So pretty much show you guys how to make a desk fan with no blades and no batteries. Let's get started. Alright, so of course you're going to need cardboard. You can get cardboard basically from anywhere. FedEx store, or if you order something online like the circuits I'm about to show you or anything like that. Next you're going to need something round. I'm going to use a paint can, but you can use a coffee can, you can use propane, anything kind of fat and round, perfectly round. That's going to be making the surface plate for our thrusters. Then you're going to need some wire, 20 AWG. Next, some linear voltage regulators. And monocrystal solar cells. A boost converter. Some copper mesh. 28 gauge enamel copper wire. And supercapacitors. You gotta love them supercapacitors. Now, we're gonna draw the circle. Make two of them. And find another thing that you can use. I'm going to use a propane tank, so that way we can do an inner circle, perfectly round, just a little bit smaller than the outer circle. It's going to help create a rim for our ion thruster plates. Oh yes. And you're going to do this 2 times. Okay, so now all you're going to do is just glue one of the rims to the other rim. Only one of these that you're going to do, the other one you'll see in future why. Make sure you have a marker and some kind of straight edge. I'm going to use a square or triangle, whatever you people like to call it. And we're just going to mark some lines right across. Now we're just going to go ahead and put little notches on the outer part of the ring. This will hold the wire in place for our positive ion plate. With the notches made, now let's go ahead and put our 28 gauged enameled wire through. When you're done, it should look like this. Now let's move on to the ground plate since we got the positive plate done. What you're going to need is copper mesh. And what we're going to do is put the copper mesh on top of one of the rings. Mark in the middle of the ring so that way it covers all and it doesn't go outside the ends. Now all we got to do is just cut it out. Make sure it fits, doesn't go out, and it covers everything. Hot glue it in. Now take your wire. I choose the black just because that's your ground. And what you're going to do is cut it. And here's a good way to strip a wire if you don't have wire strippers. Use a knife, gently roll that wire across, and then boom, you stripped your wire. Ta-da! Now you want to go ahead and stick the wire interlaced with the copper mesh. You want to try to get it in between them. The tighter it is, the better the connection. The better the connection, the better force you'll get out of these thrusters. Now go ahead and just
re-hot glue everything, and then we're going to put on the last top layer. Now we're going to go ahead and move on to the solar panel. You'll see that there's a positive and negative on there. Sorry, my camera's bad. But what you want to do is put them in series like this. So positive to negative, negative to positive, that will be series. If you do positive to positive, negative to negative, that's parallel. So you want to do 4 of these all the way into a series. And when you're done, it should look like this square. Okay, now we're going to go ahead and make the back plate for the solar panel. So you're going to need cardboard, marker, and you're just going to draw an outline of the solar panel onto the cardboard. Once you have that outline made, that lovely, lovely square, what we're going to do now is go ahead and cut it out. And hot glue it in place. Now we need a way to tilt the solar panels so that way it's with the sun. So let's make a bracket. Get some cardboard, straight edge, and of course, a marker. Mark your lines out at 3/4 of an inch so that way it's nice and small. You're gonna just do 4 and then 1 extruding. Go lightly over your lines. This will help create a crease. And then the last one where you put that little notch, big old deep cut. And it will bend easily and have the form and shape you want. Now we're just gonna hot glue that little notch so that way it stays in the shape that we made it into. Now hot glue it into the middle of your solar panels, right there in the middle. Now we got to make the second part of the hinge so that way our solar panels can tilt. Get your straight edge, Sharpie, and knife. What you're going to do is you're going to mark this at a 1 inch, um, and you're going to make 4 of notches. With those 1 inch notches made, go ahead and completely cut them out. Not gently before, completely. Now you're going to hot glue 2 of them together, and you're going to do the exact same thing for the other ones as well. This will help create the second part of the hinge. Next, we're going to take a marker and a quarter. The quarter is going to be our edge to make a nice and round, and we're going to do that to both of them. Once these are made, we're going to go ahead and cut along that nice round edge. Once you have those cut, now it's time to connect them. I'm going to use a nail, or the head of a nail, to go ahead and connect them since it's nice and cylindrical and probably said that wrong. Cylindrical. Cylindrical. I don't know. comment in this section on how to say that properly. Cylindrical? Yeah. Anyways, once you have that made, you're going to go ahead and put a dot and then right in the middle of your solar panel. And you see where I'm going with this. You're going to take that part 2 and stick it in that part 1. Use that, and then, yeah, you're just going to force it in there and just... Once you got them connected, your solar panel hinge is done. You can tilt it and tilt it to any direction of the sun. Yay! Now we have to stick it onto a base. I'm just going to use the cardboard that we're working on as the base, um, just so that way it wastes less. And now it's circuit time. Now you want to take your wire, preferably black, do the same thing we did earlier to strip it. Once stripped, go ahead and solder it onto the ground part of the solar panel. And since it's in series, there should be only one pin that is open for ground and one that is open for positive. Now you're going to do the exact same thing for the positive side, but do it with a red wire this time, just so that way it helps tell the difference. Now we're going to solder on the linear voltage regulator. I'm doing a 5 volt just so that way I don't have to do Ohm's law for the titanium supercapacitors, which now equal to 5.4 volts at full charge. So you just want to go ahead and solder on the ground wire to the ground linear voltage, which will be the middle. Now we're going to solder on the positive lead to the left side of the linear voltage. This will be your input. The right side is your output, which will put out that constant 5 volts, which we want. You're also going to put a second wire to the ground, so a second wire to the middle, and then one red wire going out for the output. Now it's time to solder up the supercapacitors. The same way we soldered the solar panels is the same way we're going to solder up the titanium supercapacitors. Just put a diode on the positive lead, um, so that way no voltage comes back to the solar panel. And then we're going to put a resistor onto our switch, so that way um, when it's coming from the voltage regulator to the boost converter, we don't overshot the voltage and then accidentally burn out our boost converter. Now solder on a red wire to the resistor. Now we're going to solder the other side of the switch to the red wire to the boost converter, and this will basically allow us to turn our circuit on and off, hence the name switch. Now let's go ahead and connect the other end of the red wire to the positive lead to the supercapacitor. Strip it first. We want to solder on the switch to the base of the capacitor, not at the end of the diode. The end of the diode will be for the voltage regulator output. Now let's solder on the ground wire from the boost converter. And then we're also going to solder on the ground wire from the voltage regulator as well. Now we got to make a little stand for our ion thruster plates. I'm making a little triangle. I marked them at 3/4 of an inch. And make sure not to cut all the way through, just gently through so that way you can create that crease that you'd like. So that way it creates the shape and the form you want. Now you're going to take that ion plate, either positive or negative, doesn't really matter, and you're going to go ahead and just hot glue them into there, that mouth of it. So just do the bottom, slap it in. Once it's in there, go ahead and get your hot glue gun, burn your finger. Glue the bottom of the uh, ion thruster, and then so that way it's nice and stuck. Because the only plate you really want to move is just the ground plate to help measure it out. All right, so now we just gotta solder on the terminals to our positive and negative. It's kind of tricky to tell what's what, but once you turn it on, wherever the force you feel is coming, if it's going back towards the solar panel, then just switch your wires around and then it will go away from your solar panel in the way it should go. And done. You're ready for testing.
So you might be wondering, like, why does it only barely push the thread and stuff? That's because it's only pushing at 1 meter per second. I could have made it stronger, but I didn't have that much resources. My 3D printer's down, and like I said, a bunch of other stuff. Also, I started working on another project, and I kind of lost interest in this one. Sorry, guys. But I hope this was a decent tutorial, so that way you guys can at least build your own ion thrusters for either a science experiment, just to show your friends or funsies, or you just want to experiment. But anyways, thanks for watching. Tune in next time, and I will be posting another video very soon. Thank you. Have a good one.